All right. So we'll get started with today's meeting. Just like a quick heads up. So this is going to be the last meeting until exams are finished. So after the winter break, there won't be any meetings until after exams. So we don't have much time to prepare because we have CCC in February, right? And exams are, yeah. When did the exams end? It's like January or something, right? The 30th. Yeah, so we're not going to have much time to prepare. So it's mostly going to be independent on you guys. But of course, if you have any questions, you can just email me. Check my email all the time, so just send me an email. Yeah, we're going to look at the 2021 problems. So these are the S1 and S2 over here. So it's a pretty interesting problem. It's called crazy fencing. So you need to paint a wooden fence between your house and your neighbor's house. You want to determine the area of the fence in order to determine how much paint you will use. Okay, so it's kind of like an application, sort of. However, the fence is made out of n non-uniform pieces of wood, and your neighbor believes that they have an artistic flair. In particular, the pieces of wood may be of various widths. The bottom of each piece of wood will be horizontal, both sides will be vertical, but its top may be cut at an angle. Two such pieces of wood are shown below. So we can see here we have bottom and the two heights here. So obviously these two don't go together because they don't have the same height, but we'll see an example later on. So thankfully the fence has been constructed so that adjacent pieces of wood have the same height. Okay, that's what I was just saying, on the side where they touch, which makes the fence more visually appealing. So the first line of input will be a positive integer n, and the second line of input will contain n plus 1 space separated integers, and then so this is the left and right heights of each piece of wood. Specifically the left height is the I. Okay, so usually like when I see stuff like this, it just like flies right over my head. Just usually what I do is I just like look into the sample input, and I just see like how does that actually transfer. So let's just read the rest of it. So the second line and the third line will be n space separated integers. So this was n plus 1 here. This one's only n. So this describes the width. So I'm looking over here and I see we have 3. So that says we have 1, 2, 3 pieces of wood here. So these correspond to 3 pieces of wood. Okay, so this 2 kind of goes here, and this 4 is kind of sandwiched in between right here. And this 1 is going in between here, and that one is going here. I can zoom in if you guys like. So basically kind of like that's what's happening here. Like we have this 2 and the 3, and then the 4 is just in the middle of it, and then we have 3 and 6, and this 1 kind of squeezes in between. That's kind of how I'm thinking of it. And now we need to actually determine this area. So how are we going to do that? Well, we know that the area of a trapezoid is equal to base 1 plus base 2 over 2 times height. Hello, welcome. We're doing the 2021 S1 called crazy fencing. Basically, we just have to determine the area of a fence with the given values for each trapezoid. So what we're doing is basically just taking the base 1. So we need to think about this in terms of the trapezoid. You can see this is a trapezoid right here, right? That's kind of what they did here. They just used the formula. But if we look at this, we take this as a trapezoid, right? It looks kind of like that. All right. Let's put this into, let's like flip it 90 degrees. Like this. Boom. Now we have this, right? And if we take this 2 goes here, this 4 goes here, this 3 goes right here. So this is kind of like we organized it in a way that allows us to easily put it into the equation. So this 2 will go into here. So this becomes 2 plus 3, which is the base on the bottom. All of that over 2, and then times the height, which is 4. So this just becomes 2 times 5 here equals 10. Right, so the 10 would be the area of the first piece of wood, and as you can see, the areas of the piece of wood, the first one is 10. We do something similar for the other ones. We should get 4.5 and 18.5. So when you add them all, you should get 4. So then when you add it all together, you should get 18.5, which is the answer. Let's put that into code. So I'm just gonna put this to the side. Now, the first input specification, which is the letter n, so the n is equal to int input. That's very simple. Now we're going to use that thing that I taught you guys a few weeks ago. It's basically like using the way to get space separated integers. So the second line of input is the heights, so we'll just do h for heights. Heights is equal to, and then we're going to do input. Right, we want to get the input, we want to split the input, right? So input.split, we'll put it into its own list with each value in it. And then you want to do map, and we want to turn all of those values into ints for each individual element in that list. And then we want to convert this map, we'll just convert it into a tuple, because we're not going to be editing it, and I just like tuples. And then the next thing, so what it's going to do is it's going to give us our list of heights. And we can do exactly the same thing for our widths. We just change that to W. And there we go. We have all of our heights and widths. Let's go print out all of our values just to make sure that we are getting everything in correctly. So if we run this, and then I'm going to go put in the sample input for the first one. As you can see, we get all of our values into our, this is in a tuple, this is also in a tuple for the height and width. They are in the correct order, and we have the value of n here. So now we can play with this now. So let's just say like our area is equal to 0 to start off with, and we're just going to go through each individual trapezoid, and we're just going to add that area. So let's go through the first one. So for trapezoid, we'll just do I and n, right? We need to loop through each trapezoid, and then we need to figure out just like how big is the area. So we're gonna do area is gonna add, and we're gonna put in from the first list. We need that. We need the first base, so that would be height I. And then we need to add the next base, which is I plus 1, right? And then all of this we need to multiply by the height. So in this case it would be the width. So they've kind of like tilted it on the side to try and confuse us. But if you keep your head clear on what you're doing, so in this, sometimes like what I find helpful, rather than like trying to like think it through every single time, if you think about it like how we did it in the question, we just sort of tilted it, right? So in this case, this was the width, this is the width, and this is the height. And then we tilted it 90 degrees, and then this width became the height, and this height became the width. If you just flip it around, that can also work as well. So we've done that, and then we get the width, which is I, and divide it by 2. And then if we just print the area at the end, we should get our answer. So I'm going to run that same sample input again, copy, paste, and we get 18.5, like the question says. So let's do a different sample input. So they gave us another example, and they said the answer should be 75, which is indeed 75. I'm going to go submit this onto the CCC grader. So here I am on the grader here, and I'm just going to go onto Crazy Fencing, and I'm going to choose a file. Let's go 2021 Senior S1 and submit. Here's our code. I'm just going to refresh this. Okay, yeah, so it's getting stuff right. Just refresh it a couple more times. And as you can see, it's pretty fast. It's nothing too complicated in terms of computation. It's just getting the idea that, hey, this is a trapezoid here, right? And I can determine the area of a trapezoid, right? I can show you guys the proof of area of a trapezoid. How did we get that formula even? Right? If you take a trapezoid and you cut this trapezoid into two, and let me change color here. So if you take this as the height, right, and then let's say we have another one. Let's say this is base 1, and this is base 2, right? So if we take the area of this, here, take this color. We take the area of this triangle, right? Base 1 times the height, right? Because it's 90 degrees right here, right? We need the height that goes all the way down to here. That's going to be this half of the trapezoid. And then we can do the same thing, right? Because this has the same height as well, right? So we have base 1, h over 2, right? Area of a triangle. I hope you guys know that one at least. Then we take this one here, right? This is the same height, right? This height is equal to this height. So here, base 2, and all of this over 2, right? You want to find the area of this triangle. And then when you add it together, right, you can factor out this h over 2, and you get base 1 plus base 2. And just the way that I wrote it over there is basically the same thing exactly. We just put this over 2 and then times height. So this is just like, if you have like good math skills, good like logical reasoning, you can reasonably just determine this like when you're actually doing the CCC. So yeah, let's go to the next question. Go with blue again. Thicker. Anyways, here we have problem J5/S2 called modern art. So the S2 is about the level of a J5, so it's pretty difficult. So let's take a look at this problem. So a new and upcoming artist has a unique way to create checkered patterns. The idea is to use an M by N canvas, I'm going to zoom in, which is initially entirely black. Then the artist repeatedly chooses a row or column and runs their magic brush along the row or column. So I'm just going to highlight this. So they can choose a row or column and they'll run it along the entire row or column. The brush changes the color of each cell in the row or column from black to gold or gold to black. So for example, if we have like a small canvas here, right? And let's say this one was black, right? And let's say this was black as well. Let's just make everything black right now. And then let's say I run like a magic brush over this middle area here. And then I run that magic brush. I'm going to change it to gold. So put a G here. G, G. Okay, that's nice. And then let's say I run my brush down this way like that, right? So I'm just gonna erase, 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 right? And then basically this becomes G, this becomes black, and this becomes G. So as you can see, like, it's kind of like pretty confusing here, where there's like the states are changing after you like go through different columns and rows. So let's continue reading. We might be able to determine some way to do this. So given the artist's choices, your job is to determine how much gold appears in the pattern determined by these choices. So we just need to count how many golds there are. So there's 1, 2, 3, 4 golds in this example. So input specification. The first line of input will be a positive integer m. The second line of input will be a positive integer n. The third will be a positive integer k. The remaining input will be k lines, giving the choices made by the artist. Each of these lines will be followed either by r. Each of the lines will either be r followed by a single space, and then an integer which describes a row number, or c, followed by a single space with an integer which is the column number. So that's kind of important. Rows are numbered top down from 1 to m, and columns are numbered left to right from 1 to n. So if we have a grid like this, right? So rows are 1 to m, so 1 to m. So m is equal to 3 in this case, and then columns are 1, 2, and like that. Okay. Okay. If we're intending to solve and get all points, so we're just gonna kind of ignore this for now. Output one non-negative integer, which is equal to the number of cells that are gold in the pattern determined by the artist's choice. Okay. So let's go get our sample input in. What we're going to do is we're going to go to a new file, and what we're going to do is we're going to get the input specification. So we have m is equal to int input. We have n is equal to int input. So these are the row and columns. And then we have k is equal to int input. Yeah. And then for I in range k, you're going to get k lines, and it's either going to be R or C. So we'll just say command, comma, value is equal to int, or we'll just do tuple map. We actually don't need that. We can just do input.split. So input.split will give us just like a list with the value. So it would be like r, comma, 1 like that. And what this does is it will assign the r to the command variable, and this 1 will go to the value variable. And what we'll be able to do is we'll be able to kind of just determine. We'll be able to get two inputs on the same line. And we don't have to use the tuple map input int and whatever, right? So what we can do is I'm actually going to change this to the index just to make it a bit more clear. And our index we're just going to subtract 1 from it because they started off from 1 all the way to m or n, right? We wanted to start from 0, so we're just going to subtract everything by 1, and that'll keep us in the right way, in the right index. Convention. So what we're gonna do now is just kind of analyze how this can work. So I'm gonna open up a paint, and if we think about it, right, they're gonna give us tons and tons of commands and operations. So for example, we're gonna get R1, C1, right? So let's say we get R1, so I'm gonna change it all to, you can't see that very well. We'll just say it's red, right? R1, all right, that's the first row. And let's say we get C1, right? And then this will change back to black. I'm gonna make this thicker. There you go. Let's change back to black. And then this one will change to gold. So will this one. I'm just gonna change these to gold as well, right? And then we would be able to count. So 1, 2, 3, 4. Okay, that's pretty cool. Now, the big insight for this question is to realize that it doesn't matter the order. You can change the order no matter what. So let's say we wanted to start off with C1, R1, right? It's going to give you exactly the same result. So let's do C1 first. So C1, we're going to color in this entire column here, right? And then R1, so we're going to color in this, we're going to color in this. This is going to change to black, right? And as you can see, these are exactly identical. Even though we changed the order of these two, it doesn't matter, right? And this insight allows us to kind of play with this a little bit. So let's say we have another grid here, and we got R1, C1, R1 like this, right? So this logic that we determined over here, that it doesn't matter the order, it allows us to do something pretty cool. What if we put this R1 right here, right after this R1, but before this C1? So what would that mean? So you're gonna color this in, right? So this is R1, and then we get R1 again, right? So you basically just color everything black again. This goes all back to black, and then you do C1. What you might notice is that this is exactly identical as if we had just not done this R1 operation at all. It just canceled itself out. So this can be useful, so we can kind of like if we have any operations that repeat twice, we can just remove them. But there's one thing we have to be careful about. What if there was another R1, right? It's gonna do the C1, right? And then let's say we put this R1 here as well. It's still gonna put in that R1 as well, because right, this one has nothing to cancel with. So we just have to be careful that every even number of times that we do it, then it doesn't matter to us. So here's what we're gonna do. I'm gonna put this into code. So what we're gonna do is, before we even get any of our inputs, let's make the canvas. So canvas is equal to, and I'm going to use list comprehension to just generate an entire canvas for us. So I'm going to explain it in a second. Rows. Okay, so I'm just going to change this M to rows, this N to calls. And I'm going to keep the K the same. So I'm just changing this because I don't feel like remembering whether M is rows or columns. Just you can name it whatever you want in your code, just to make it more readable. But anyways, what we're doing is essentially making this thing, right, a rows amount of times. And then this is actually a list. So we're putting, let's say we have 3 rows and 3 columns. It's going to make 3 of these lists. So each of these lists represents 1 row. So that's why we have it in range rows. So basically what it's going to do is going to make false, false, false 3 times. So like that, right? And this thing here, false for I in range calls, there's 3 columns, so it's going to make 3 falses like this. So that this part that I've highlighted equals this, for underscore and range calls. And then what we can do is we can actually copy this 3 times using another list comprehension, right? And that makes an entire array like this. Now, why is this useful? Well, if you actually look at it in a different way like this, this is actually like the canvas, right? If we have this false representing black, and we have true representing gold. Now, why is this useful? Well, there's actually a pretty neat thing you can do in Python, right? You can set not true, right? We can set a variable is equal to true, and then we can set another variable equal to not true, or not x. Now, what is not true? That is equal to false. So in this way, we can quickly switch the values around without having to do something like black and gold. So rather than saying something like square is equal to black, and then instead if square is black, right, then we do square is equal to gold, or if square is gold, then square is equal to black, because that's too much work for us. We can take advantage of certain data types like booleans, so in this case true or false. We can make our code a bit more efficient and a bit more easier for us to code. After all, that's why we like to code, because it makes our lives easier, but sometimes it makes it harder. Anyways, for our index, we have to make sure we convert it to an int. So I forgot to do that before, but make sure you convert that to an integer, and then we subtract 1, and this will set it to an integer value. Now, if the position, or if the command is equal to r, so this is a row operation, then we need to kind of keep track of this in a variable. So we're going to make another list. So we're going to call it row changes is equal to false for underscore in range rows. And this underscore is just a convention we use in Python to show that we're not actually going to use this value. Sometimes you'll see for I in range this, then you're not actually using this I anywhere. So you just put an underscore to show that we're not actually using it. And we'll do the same for the calls. Call changes. And this needs to go for I in range calls. Good. Now, let's go and store this into our list. So row underscore changes is equal to index. So the reason that we made this into a list is that for every row, we keep track of how many changes we made to it, and like the way that we kind of like dealt with this, like there needs to be 2 of them, and if it's an odd number, then we don't need to like do anything. We're willing to do it once, right? We can actually keep track of this using our Boolean variables. So that's why we have this true or false thing here. So false represents black, right? And then true, so basically if we make a command to this line, then we'll just do not row changes index. And then this, we can do exactly the same thing with the columns. So we can just do an else here because it's not going to give us any other options. And we just change this to call changes. Don't forget to change both of them. Perfect. Now, we've got all of our commands. Let's actually like change some stuff now. Yeah. Alright, so for I in range rows, so we're going to loop through every single row, and if row changes I, then for j in range calls, we want to canvas ij. So we're basically just looping through each row, and then if there's a change on that row, then we're going to go through each value in this column, and we're just going to set it to not canvas ij. So these ij values, I represents the row and j represents the column. The reason we have to do the rows first is because that's how we made our canvas. Right, our canvas, we have rows on the outside and columns on the inside. I think it's pretty important to understand the difference. So before I was showing you, I had this false, 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 right? And this represents each row, right? Like this. Well, there's a different way to do this as well, where in this case, I'm just going to make it so that it's a 3x2 just to make it a little bit more visible. So here we have 2 wide by 3 tall. Let's say that we had we're storing it in terms of columns. So our first one would have 3 values, and like that. It should be like this. There. So this is still 2 wide by 3 tall, but we're just storing it in terms of columns. So this is the first column, and this is the second column. So if you kind of like tilt your head to the side, you can kind of see it. So there's just like different ways we can store a 2D like a table, but I prefer doing like the rows, storing the rows, because that's just readable to humans in a code interface here. But that's just my preference. So that's the reason we have rows first and then calls. And then we just sub it into the values here, and we can just like set it to not it. So if it's false, it becomes true. If it's true, it becomes false. Alright, and in this way we minimize the amount of operations. If you didn't do all of this like thing here and you just went straight into changing each row and column, you're gonna find that if you run in the compiler, the CCC is gonna be too slow, and that's no good. We want it to be fast enough. So that's why we did all this like optimization thing here with only changing it when absolutely necessary. And the next thing, we can do almost the same thing. So for I in range calls, if call changes I, for j in range rows. And now be careful, because we're actually going to switch it around. We want to do j and I is equal to not canvas j and I. Now the reason we're doing it kind of flopped around like that is because here we're looping through the calls first and then the rows. We want the rows to be the first one because that's how we stored our canvas in terms of rows. And then we put in calls in the second value there. So that's why it's switched compared to this one we just did. Now, we can do a total is equal to 0. And we just loop through for I in rows, for j in range calls, if canvas ij, And you can equal true, but this is kind of redundant, so we can just remove this equal true. And if this is true, right, if it's a gold value, then we'll just do total plus equals 1. And then all we have to do is last step, print the total, and we are done. Alright, let's run this. I'm going to get out sample input. So the first sample input is a 3x3 grid. It's R1, C1 is the thing we've been doing so many times, and gives us the right answer of 4. Let's do another one. So this one's a little bit bigger, right? And it gives us 10, which is exactly the same as the output that you should be getting, so that's great. Let's go submit this onto the CCC grader. So I'm going to go in here, and we're going to go Modern Art, Python 3. Make sure this language is set to the right one that you're using. So if you're using Python, using PyCharm, you're most likely going to be putting in Python 3. And if we submit it, make sure you're submitting to the right one as well. Modern Art should see that we get correct answers. Perfect. As you can see, it's pretty fast. We'll see as it gets to these later subtasks. We can actually read what they're going to be. You can see here the last 5 marks. So here at the bottom, the last 5 marks here, it's going to be M and N. So this is like a 5 million by 5 million table, and we're going to do like 1 million operations on like the grid here. So it's going to be like might be changing these like 1 million times. 5. Yeah, okay. Let's see how we did. As you can see, it passed every single test case. Plenty of time to spare. We used a little bit more than half the time in this one. It's okay. I'd recommend like for later problems doing like C++, because that's going to be a lot faster. You might be able to get away with like a little bit of a less optimized solution. But Python is easy for me. I like Python, and yeah, that passes all the test cases, and that is it for today's meeting. Hopefully you guys enjoyed that and maybe learned something new. Yeah, I'll see you guys next week.